We're talking about solving systems of linear equations by graphing. We haven't even learned this lesson, and it looks like all of us pretty much did exactly what we were supposed to do to find the solutions on these graphs. So that's awesome. We're already off to a good start. Some vocab. A system of equations is just any time we have two or more linear equations in a problem. So a linear equation is what we spent all of last unit talking about. Those are like straight line equations. Y equals mx plus b is one of the forms. And if we have two or more of those in the same problem, we have what is called a system. We are going to talk about the solutions. A solution to a system of linear equations is any ordered pair that makes each equation in the system true. So basically, if I take any point, an ordered pair, I plug it in for x and for y, it should make every single equation true. That means it is a solution. Hopefully, you saw when you guys were doing your graphs that the solutions we were finding were where those two graphs crossed, because at that point, both of the graphs overlap that one point. So this solution on a graph occurs at the intersection of the lines. Sorry, I don't know why my pen just started writing all weird. Solution, intersection. Okay, that's better. We have three scenarios that we're going to see. The most common one that you see is like what you just saw in these problems, where we have one line and a second line, and they are both overlapping at one spot. All right, so that one intersection point means we have exactly one solution. And that answer to our problem would be a coordinate point xy. We have some other scenarios that we see a lot of the time. So another scenario we might see would be something like this, where our two lines never intersect. What do we call two lines that never intersect? Parallel. That's one of our vocab words from last unit. So if two lines are parallel and they never intersect, then they never overlap, we have no solution. So the answer that we would write, instead of a coordinate point, we would write no solution. And this happens when we have parallel lines. Lastly, what might happen when we graph a line is I might graph one line, and then my second line goes right on top of that first line. So when the two lines are exactly the same, meaning they're overlapping in every single location, that means we have infinitely many solutions. That is what we would write instead of like a coordinate. This happens when we are looking at the same lines. Questions on these three scenarios? Okay, so let's show you how to solve by graphing, which you essentially already did on the boards. Taking a look at number one, remember that the form that we graph in is slope-intercept form. Slope-intercept form looks like y equals mx plus b, where m is the slope, b is the y-intercept. That's how we graph lines. So I'm going to take a look at these equations. Do we see that the second one is already in the form y equals mx plus b? So I'm going to figure out what's my slope. What is the slope here? 1. There's an imaginary 1 that we can't see in front of that x. So 1 over 1. And then my y-intercept is 2. So I'm going to start there. Y-intercept of 2, use my slope 1 over 1 to draw a nice line. As nice as you can possibly make it. Okay, that's kind of the easy one. Now take a look at that top equation. What am I going to have to do to that top equation to get it to be in a graphable form? We're going to need to get rid of that 4 because we're solving for y. So I'm going to go ahead and drop this down. I'm going to divide everything by 4. So y equals 2x plus 8. I'm going to go ahead and graph 8. Up here is my y-intercept. Use my slope, which is 2 over 1. Up 2 over 1, up 2 over 1, down 2 backwards 1, until we get about there. Oh, sorry, this is an 8. This is a 4. Oops. Back it up, back it up. Okay, so there's my lines. Hopefully, if you graph them nice enough, you should be able to see exactly where those 2 points intersect. Can we see it? Mine might not be graphed nicely enough, but I can kind of make out that those 2 lines intersect at that point right there. So the solution to this system of inequalities would be the coordinate -2, 0. Everybody okay with that? Can we go ahead and try example number 2? Graph your 2 lines. You might have to do a little bit of manipulating. Give it a go. All right, I'm going to start manipulating these equations while you finish off graphing those lines. I'm trying to get both of my equations to say y equals. So I'm going to go ahead and start with this top one. To get the top one to say y equals, slope-intercept form, the first thing I'm doing is subtracting 2x. Anytime we move a variable, it should be with addition or subtraction. And then I'm dividing everything by 2. There's my first equation. Second equation, a little bit easier. I'm going to take it, and all I have to do is add 3 to both sides to get y equals 4x plus 3. Hopefully we got those. Everybody get those? Now I'm just going to graph. So with my blue line, I'm starting at the y-intercept -2, and I have a -1 slope, like so. And then with my red line, I'm starting at 3, and I have a slope of 4. Oops. So again, if you graphed it nice enough, you should be able to see where your 2 lines intersect. They are intersecting at this point right here. That point is -1, -1. Any questions on those 2? All right, flip it over. Yeah, we have to do more. Example 3, what do I do to that top equation to get it to say y equals mx plus b? All I got to do is subtract the 1/2 x. So y equals -1/2 x minus 3. What do we notice about my 2 equations now? Same slopes, different y-intercepts. What does that mean about these 2 lines? So they are parallel. So without even graphing them, what do I know my answer is going to be? No solution. Let's just graph them just to see what it would look like. Maybe you didn't see this right away. That's okay. If I go ahead and start graphing y equals -1/2 x plus 2, that starts here. And I'm going to use my -1/2 slope. So something like this. And then I'm going to do my other line, starting at -3 as my y-intercept. Same slope. Something like this. So we can see that these 2 lines, they don't intersect. So if you didn't notice it here in the equations, you should notice it when we get to that step. They don't intersect. Any questions on that one? Okay, let's take a look at 4. My first equation is already in the correct form. What do I have to do to that second equation? Divide everything by 4. Y equals 3x minus 3. What do I notice about my two equations? Same lines. So what should my answer be, Branson? Infinitely many solutions. And I'm only going to graph one of these because they're the exact same line, but you should notice that -3, slope of 3, your lines would end up just overlapping like so. Any questions on these two special cases? It is not enough if you just say, oh, this one's parallel, that one's the same lines. I will not take that as an answer. I need to see no solution or infinitely many solutions. Does that make sense? Okay, so for our application, I'm going to go over this like real quickly. I just want to talk about letter A to make sure we all know how to set these up. Mr. Witkowski is hosting an awesome New Year's Eve party. To make this event as awesome as possible, Mr. Witkowski has decided to hire a DJ. One DJ service, DJ Lilo Entertainment, charges $4 for every hour of the party, and another DJ service, DJ Pepper, charges a flat fee of $4 and $2 for every hour of the party. Help me set up these equations. What did my first equation for DJ Lilo look like? You set it up on the boards. What did it look like? Autumn. Perfect. 4x. There is no flat fee for DJ Lilo. And then what about DJ Pepper? Perfect. Any questions on that? So it was the same thing. We were graphing. We were making sure that they intersect somewhere, and that was our answer. How did we determine which DJ service was a better price for the 4-hour party? How did we know? We looked at our graphs. How did we figure it out? Jaden? You can plug in the 4 for X. X is the number of hours, so you could plug that in. Some of us, maybe we looked at our graphs and we looked at where the 4-hour was, and we determined which one was the lower price at 4 hours. Okay, so there's a lot of different options there. Last thing here. Use the given equation to write a second equation so that the system of equations would have, we're starting with letter A, there is no letter A, one solution. Give me any equation that would work with y equals -3/4 x plus 4 to give me one solution. Sure. Y equals 2x minus 2. This works because it's not parallel to my original line, and it's not the same exact line. So we know everything other than those two cases is going to give me exactly one solution. So you could have told me y equals 2,000,000x minus 17, and it probably would have worked, right? Any equation that is not the same slope as that equation would work. Fine. Give me an equation that would give me no solution. Autumn. Perfect. This has the same slope and a different y-intercept. Therefore, they are parallel and would have no solution. Finish it off. Give me the equation that would give me infinitely many solutions. Y equals -3/4 x plus 4. That's the exact same equation. Any questions on this?